Good afternoon. Welcome back to the stoichiometric lesson. So we'll say some more typical problems in arriving the oxidation number. Very crucial. Please listen carefully. One of the question is fluorine is reacting with ice. Fluorine is reacting with ice, and the change is means H2O solid reacting with F2 fluorine, giving to hydrofluoric acid gas and HFO or HOF. These two are the products. Now you tell me whether it is a redox reaction or not. If at all a redox reaction, how can you justify? That will be very complicated. Means if it is a more tricky question. Now water is reacting with F2. So if you see F2 oxidation numbers are 0, hydrogen is +1 and oxygen is -2. Left side reactants is very good. In the right side, hydrogen is +1, fluorine is -1, okay, and HOF. Now what is to be written here? H is +1, okay, fluorine is -1, okay, total compound it should be 0, it is already 0. Then what is the oxidation number of oxygen? It is a typical. Most of the people will stuck it here only. Now first question answer is whether it is a redox reaction or not. Yes, it is a redox reaction because the fluorine from 0 it has gone to -1 in both the cases. Hydrogen from +1 it is only the +1, whereas what is the change is oxygen change. So assign first oxygen as what is the oxidation number, then you will come to know or you can justify. In the H2O case, it is oxidation number of oxygen is -2. In HFO case, it is 0. It is 0. A very typical this thing, and most of the time people will not accept to keep as a 0 on oxygen. So it is a redox reaction first. Redox reaction. Then the changes are oxygen -2 to 0 and fluorine from 0 to -1. Okay, that is a typical question. Now coming back to the some 2-3 problems we'll see, then we'll switch over to this thing. What is the oxidation number of sulfur S8? For a molecule, rule number 1 is as per that it is 0. So similarly P4 also it is 0. Fine. Then now typically one more typical question, Fe3O4. Fe3O4. Now what is the oxidation number of iron? 4 to the 8 minus 2 means 4 to the -8. 3 means 8/3 plus 8/3. No, answer is wrong. So the answer is iron will have in between of 2 and 3. Means iron is having 2 oxidation +2 and +3. Answer always you write like this one, because iron cannot have the in between. It has a both divalent and trivalent in the Fe3O4. Okay. Next one more small typical one is F2O. Some people write OF2 also. F2 or OF2 is same. Now what is the oxidation state of oxygen? So fluorine is more negative, so it is -1, so here it is +2. Oxygen is here in this case +2. Okay, so these are some of the some more typical questions. Tomorrow we'll see. Now today we'll switch over to balancing of redox reactions. See, so far balancing of normal equations we have already seen. Now we will see the balancing of redox reactions. In this there are two methods. One is the oxidation number method. So far whatever we have here, the title is balancing of redox reactions. In this, there is oxidation number method, oxidation number method. Second one is half reaction method. Some people say half reaction method. Some people say it is ion electron method. Both are same. Ion electron method. Both are same. The second method is more useful in the case of the ionic equations, but most of the time we use normally the oxidation number method for balancing the redox reaction. See, there are 5 steps in the balancing the redox reaction. Okay. Now, step 1 for the balancing. Write the correct formula. Formula is written. Then identify the oxidation fellow and oxidation element, and which changes oxidation number and reduction number based on this, based on their numbers. Then calculate increase or decrease per atom. You always remember it is per atom or per mole or per ion. That is the third. Fourth one is adjust the coefficients. Fifth is slightly cumbersome, but is if it is an acidic medium, add H plus ions or H2O. H plus ions or H2O in the case of the acidic medium. H plus for the acidic medium, H2O is the basic medium wherever the deficiency is. Or add H2O molecules to acid medium or OH minus is in the basic medium, whichever is the convenient way, wherever the deficiency. We will start doing one small problem, then you will come to know and we will understand. The question is, write the net ionic equation of a potassium dichromate with sodium sulfite reaction giving chromium ion and sulfate ion. Cr2O7 minus 2, potassium dichromate, chromate ion we have written, plus SO3 sulfite ion minus 2 gives aqueous and all I have not written, chromium plus 3 plus SO4. This is the equation. Now we are solving this with respect to the oxidation number method. Now here chromium is 7 to the minus 14 out of minus 14 minus 2 removed, so it is minus 12. So chromium is plus 6 here, plus 3 is the right side. That means it got reduced. Reduced is chromium is reduced from plus 6 to plus 3. Sulfate is 3 to the 6 minus 2, it is 4. It is plus 4. Here it is plus 4 to the 8 minus 2, it is plus 6. This got oxidized. Sulfite has become sulfate and dichromate has become the chromium ion. So now identified. So first step is over, right? The correct equation is over, identifying is over. Then now the third step is the calculation of the oxidation numbers from left side and right side. Here 2 ions are there. So here it is changes from 6 to 3. So 3 for ion, for 2 ions it is 6. Here change is plus 4 to plus 6. So change is only 2. So the charges are not same. So it is to be multiplied with by 3. So what I am writing now, Cr2O7 minus 2 plus 6 is anyway plus 3 SO3 gives chromium plus 3 and 2 chromium plus 3 SO4 is 3 SO4 is SO4 minus 2. This we will write later. Okay. Now, next step, what we have to write? It is in acidic medium. So, we have to add H plus. Cr2O7 plus 3SO3 plus H plus gives chromium plus 3 plus 3SO4 minus 2. So, we added. Water is at the other end. Now, H2O. How many charges are changed from this side to this side? This is plus 6, this is plus 3, this is minus 2, this is minus 2, this is plus 4, this is plus 4. So, now how much is to be here requirement? 4 2s are 4 oxygen is less, so 4 2s are 8. I think it is balanced now because the H plus is added in the fifth step as acidic medium. So, slightly difficult. Do it for some 2-3 more problems. We will see one more problem tomorrow. We can come to an easy way for the balancing of the redox reaction by oxidation number. Thank you.